Okay, I'm going to do my best to explain this. It's a formula that my dad came over and came up with the other day. It's a way of getting these magnitudes and translating them into some sort of a size value that's going to look relatively accurate. Okay, so what are we working with here? We got our magnitudes of our stars. These are on what we call a logarithmic scale. And what a logarithmic scale is, let's say for example we have an x and a y axis. A logarithmic scale would look something like this, as in it would start at a negative infinity, and it would end up at a very flat value. In this case, it starts at negative 26. The sun is at negative 26, and the very faint stars are at about 12 or so. So these are the sort of this is a scale that we're working with. I'm going to redraw that again. It's more like this. Okay, negative 26 to 12. Now, this is what Dad's sort of got his head around. Is he said that what we want to do first of all is we want to invert this, right? That makes sense. So we want to say instead of being a really low number, we want it to be a really high number. The sun being closer should be a bigger value. and he also says that this should be linear. It should so instead of an exponential or a logarithmic scale going down, it should be a linear scale going down like this. It'll look more accurate, going from the sun to a faint star. Okay, so let's see how we'll go about that in the code. We'll jump right in and start writing some code. Okay. Let's see, what do we got? I'm going to open up our code. Okay, so we have our scale at the moment is screen scale multiplied by magnitude. I'm just going to comment this out for a moment. Okay, first of all, let's get a clamped value. Okay, so this is a way of saying we know the sun is negative 26. Alpha Centauri is something like negative 2, I think. And then things will get progressively smaller and smaller. And most of the values are somewhere between 0 and 10. So let's go ahead and clamp those values, because we don't want the sun taking up this massive amount of space when working with these scales. So let's go ahead and say float. We're just going to call this mag log is going to equal in clamp in 0 dot pos. It's not pos rather. It's mag.x. We're going to clamp it between 0 and 10. Okay, this will give us a reasonable amount of room without any wild numbers that are way too big or really small. Okay, once we have that logarithmic magnitude, let's go ahead and create this linear magnitude that we want to do. Okay, so say float maglin is going to equal pow. Now this value that we're going to raise to the power of, this will be a variable we can play with, and it's going to be called mag delta, as in the difference between the magnitudes of the stars. If it's a really big number, they're going to look really similar. If it's a really small number, there'll be a big difference between them. Okay, so we're going to raise mag delta to the power of negative mag log. Okay, so the negative is going to invert this, and the and raising it to the power is kind of going to undo the logarithmic nature of it. All right, so now we have mag log, mag linear. We also want to say we might end up getting some really big values here. So for example, the stars that are a bit closer might end up being uncontrollably big. So we want to again clamp that. We want to make sure that we can come up with some sort of limitation for how big the stars can get while still being able to change the delta of them. It'll be more intuitive once we start playing with the graphics. Okay, so I'm going to say float mag clamped. Now that's going to equal clamp underscore mag linear with, I'm going to call this another variable that we'll play with, and this will be mag max. Mag max. Sounds like Mad Max. Oh yeah, so we're going to clamp that between 0 and mag max. Okay, yeah, then we're going to get our screen scale, and our scale will be screen scale multiplied by mag clamped. Okay, let's go make sure that we're declaring these variables. So I'm going to say float underscore mag delta. We also have a float underscore mag max. Little semicolons at the end there. Make sure it's looking neat. Okay, and we also need to declare these variables up the top here. I've written down some nice variables to get us started with. Let's see, I'm just going to copy this over. Now our radius is going to behave a little bit differently as well because we're bringing all these extra values in. So I'm just going to replace these with a new sort of new values here. So the radius is now going between 0 and 1. Our delta magnitude, this is going to be the difference between how big the stars are. For example, a really massive number that would all look the same size. And mag clamp is the biggest that magnitude effect will have on the size. And I'm just going to rename this mag clamp to mag max. Okay, let's see how that goes. Our radius. Alright, so let's check that radius number. Okay, 0.014. Let's see how that looks. 0.014. No, it's got to be a bit bigger. Okay. Yeah, so as you can see, we're getting a bit more of an accurate look of how our stars are. Playing with the radius can change the overall size of all the stars. Playing with that maximum value will change so for example, now I'm allowing them to get really big, and now I'm saying, oh no, I want them rather to stay at this size. I'm going to make this all a bit bigger. Okay. There we go. Okay, so also our delta magnitude is saying what can the difference between them be. So if the delta magnitude is at 1 raised to the power of anything is going to be 1. So that's the difference between the size of them. So at the moment, only the brightest stars are going to be big enough to see. And so yeah, the delta magnitude, that's like sort of the population of the sky. The radius maybe would be like the brightness, and maybe the maximum magnitude would be, I don't know, how fantastic you want those bright ones to look. All right, now there's one more thing I wanted to do. You might notice how the stars are kind of rendering behind the constellations. Maybe we want them to render in front of them. So I'm going to go ahead in my star shader. I'm just going to add we're just going to add a little +1. This will mean that it'll render in a transparent queue +1. So the constellations will render before our stars. Okay. Let's see, make sure that the render queue is from shader, and we can see that our stars are rendering in front of the constellation lines.